Hello, hello everyone. I'm gonna wait just a couple minutes for everybody to join. Sorry for being slightly late. Hello, hello everyone. Okay, so I think we can slowly start. Hello everyone. Thanks for joining here. This is going to be the very first iteration of our series on a new app that we've been building recently. It's called Gossip. So where does gossip come from? It comes from the idea that existing messaging is not very satisfactory. Uh, Existing messaging systems are extremely centralized. I mean, we've seen it recently, even with Signal crashing as soon as AWS went down. So it's not a good sign. And we wanted to make something that's more resilient, especially in the wave of all these attempts to control speech. As we've seen chat control in the EU, for example, and unfortunately, when we look at it, almost all of the existing messaging systems would not be able to function under chat control, at least not at a level of privacy that's satisfactory. So, because of the way we work, because of the way we are, we want to build something that preserves freedom of speech for the users. And that's why we started working on this Gossip app. So, just to give you a general idea here, Gossip is the little symbol on the right here. And if you look closely at the comparison table here, we see that we have here Instagram, Telegram, WhatsApp, and Signal, the most common communication systems nowadays. And I have ranked them with respect to a few things. There's, of course, many other aspects that we can look at. Typically, uh, end-to-end encryption, it means that nobody can look at what you're writing, and nobody except the person you're talking to can see what you're writing. Well, it's not true on Instagram. Meta can look at all your messages. On Telegram, by default, the server can see in clear the messages that you're sending. You need to actively opt in secret conversations for them to actually hide it. On WhatsApp, it's by default hidden, but we've seen that there's a few problems on this side. On Signal, it's by default hidden as well. And on Gossip, we're gonna make sure it is as well. When it comes to phone numbers, unfortunately, most of these apps require you to have an active phone number for you to be able to use them. Typically, WhatsApp, Signal. Recently, Telegram have rolled out an option that's paid that allows you not to have a phone number. But again, if you need to pay, it's not truly decentralized. So this is something we want to fix as well. Why would you need a phone number to be able to communicate? Because in most countries, unfortunately, uh, most in most countries, and more and more countries nowadays, you need to be registered to almost pass a KYC to be able to get a phone number. So this is a bit of an issue, and we want to solve that by not requiring a phone number. Then comes the question of a truly decentralized backend. Well, uh, whenever you have a fully central system, you can that system can stop. This can literally stop anytime. Can be stopped by its creators. Can be backdoored maybe. There can be issues. They can selectively censor some people, not others. Alt is a bit of an issue, and that's very present with Instagram. Instagram controls everything people do. People say they can ban them, they can stop them, they can censor them. The whole system can also be stopped on demand. Same thing for Telegram. Same thing for WhatsApp. Same thing for Signal. Actually, the best case scenario is Signal, but even there, we saw it as soon as AWS fell down, Signal stops. So that's a bit of an issue that we're trying to solve. And here we're going to make sure that the backend is decentralized. Then comes a last aspect that is quite important, but not many people know about it. It's called sealed metadata. It means that, okay, these messages go through some kind of backend or through some kind of server or whatever is in the back that propagates the messages. If the metadata of the messages is not hidden, that entity will be able to know who is talking to whom. Even if they're not able to see the messages, they still know who is talking to whom. Typically, on Signal, the server knows which phone number is talking to which phone number at what date and what quantity of data is exchanged. So if tomorrow they want to censor one person, they can. If they want to censor under certain criteria, they can. And that's something we want to solve as well by sealing, by encrypting the metadata itself, so that nobody knows who's talking to whom. So these are kind of the main guidelines here. Also, in terms of censorship, we don't want to rely on centralized app stores. We want people to be able to always use the app, even if it's censored on app stores. So here's kind of a general summary of all the aspects we are focusing on. First, because there's no phone number, people need to be able to log in somehow through a passphrase. So here you're gonna have your password and you're gonna log in through your password, and that's where your account resides. Then when it comes to not being censorship resistant, we don't want central powers like Google or Apple to be able to just censor the app on app stores and suddenly it doesn't work anymore. That's why we're going to have an alternative progressive web app available directly on Masa's decentralized web. So it's going to be fully censorship resistant here. Then same thing for the backend. We don't want a central server for backend. We want a peer-to-peer gossip system that's going to reuse the gossip system of Masa. We're going to look at it a bit closely later. And of course, the sealed metadata. Again, we want people to be able to communicate without anybody being able to see what they're writing. So we will have post-quantum cryptography in a way that even quantum computers cannot break it. We're going to be using end-to-end encryption by default. And we're going to use something called the double ratchet. That's going to ensure that even if somebody somehow breaks one message, they cannot read the previous nor the next messages. And finally, we're going to have something really cool, which is plausible deniability by default. So this means that if you talk to someone and that someone leaks the conversation, you can deny you ever wrote the conversation. There's no cryptographic proof that you actually did that. So then comes other stuff here. Typically, by combining all these features, no outsider knows who is talking to whom. Nobody can stop the system. It's resistant to classical and quantum computers. Nobody can see the contents of the messages, and leaked conversations are not incriminating. All these to achieve three big aspects: privacy, resilience, resistance to censorship, and safety. So that's all these aspects is how we combine them, and that's how we achieve these three big targets. So just to quickly look at what you guys are saying, so many arrows. Yes, that's basically what each thing implies. Nice to see you as well. So you guys have examples: Session, Blair, Briar, SimpleX, Chat, etc. Yes, there are a few attempts at building these kind of things. And we believe that the more attempts there are, the better. And on our side, our positioning is a bit different because we truly have here zero backend. We have plausible deniability, post-quantum cryptography by default, and something that most of these guys don't have, which is sealed metadata. And that's our approach to it. And we believe that we need to be able to completely disappear ourselves from the equation. And this thing needs to still run forever. Typically, if tomorrow chat control arrives and we need to disappear from the equation because we cannot be linked to it anymore, we need to be able ourselves, the creators, to completely disappear, and this thing will still run and still have all these properties. So that's kind of difference compared to existing solutions that are either partially decentralized, sometimes federated, either use a central server, are not post-quantum resistant, don't have sealed metadata. That's where we're trying to unite all these together into one product. So if we look at a bit closely at how these things work, so these boxes on the left here, the first one is we log in through a passphrase only. There's no phone number. So this means that under the hood, the user is going to enter a passphrase that's going to be special to that user. This is going to allow the system to derive some kind of root ephemeral secret from which a set of keys are going to be derived. A Massa secret key, an MLKEM secret key, that's a post-quantum key exchange, essentially cryptography encryption key, MLDSA for signatures post-quantum as well, and all the associated public keys as well. And by hashing all the public keys, we get the unique user ID that identifies the person inside the system. And that's literally how it works. So just knowing the passphrase, you can derive all of this. And that's what identifies, this user ID is what identifies someone inside the system. So anybody is able to create as many identities as they want, as long as they keep the passphrase. Then comes the app itself. We don't want the app to be easy to censor, so we will of course distribute it on the traditional app stores, but we also want an alternative that will be reachable even in censored areas, and if people decide to censor it. Typically, a progressive web app, for those who know, will be hosted directly on Massa's decentralized web. So even if everything else is censored, people are going to be able to access it and install it from there. So the biggest challenge is to incentivize Massa token holders, which are node runners, to participate. Thank you for the question. So that's where it becomes interesting, and that's what I want to discuss with you as well. It's actually my next slides. So typically, we don't want any backend. We want to peer-to-peer gossip only, and to use sealed metadata. So the basic idea would be to just use the Massa blockchain, typically, and the Massa blockchain could be used to store that. But if you look closely, here we don't need a whole consensus. We just need part of the Massa blockchain. We need the part of the blockchain that currently exists and that propagates blocks and transactions. It's the gossip area, the gossip system. So the nodes in the Massa network are connected between themselves, and there's a whole bunch of securities that allow a whole bunch of systems that are secure that allow the nodes to communicate pending transactions, blocks between them. The idea would be to extend the features of the Massa network to allow anyone to reuse this existing system inside the network without adding significant extra load on the network. So it should have very minimal consequences on the node runners. And we would reuse existing infrastructure that already gossips the blocks and the transactions. So that's kind of the general idea, but we're ready to discuss anything with you guys here. So the way it works is that we have the Massa network, the nodes. The gossip system would not require any consensus, actually. It's going to use the lower level of the Massa network. So a user would just encrypt a message and send it with a secret retrieval key. It's going to propagate in the network. The nodes are going to keep a short cache of these messages. And then a separate user can just retrieve this message that is destined to him, but by seeking the message at a secret retrieval point in the cache. So nobody else knows that this is destined to him. And so the user too queries the data and gets the data. And then from there, it can decrypt the data. And that's how we transmit messages from one person to the next. If you wish, the Massa network, through its gossip system, acts as a multi-hop network. So unless user 1 and user 2 use exactly the same node, which we will discourage, just like in any kind of onion routing, people won't be able to see who's talking to whom. So that's the general idea. Um, so there's a few questions here. That's a big challenge. What's the strategy for that? To bring value Masa tokens and to node runners. So this system needs to be free fundamentally. We cannot make the users pay if they don't pay for Signal. But remember, the Signal infrastructure, for example, costs, if I remember correctly, $15 million a year. So we don't have the money to pay for that, and we don't want to make the node runners pay for it either. So there's going to be, so for now, we're gonna deploy a simple system that resembles a simple messaging system. On top of this, they're going to be paid features. And the idea is that these paid features would be paid in Masa. And the paid feature is where we would have an actual economy. That's where we could incentivize everyone in the network. For example, we could demand people to burn Masa tokens, which would create a demand for Masa in there. So that's a quite interesting point here, and that would be a second step, the commercial step, and we're gonna of course discuss with you guys. So node runners won't have any say if they want to participate or not. That's an interesting question. Today, node runners, of course, have already a say whether they want to propagate transactions or not. They could modify the software and not propagate the transactions. Same for blocks. Of course, that would damage the network. That would make the network work less well. Another question would be for you guys. It's a bit of a mystery for everyone. In the Bitcoin network, what's the incentive for node runners to propagate transactions that were not yet included in a block? I'm a node runner in Bitcoin. Why would I do that? Why would I propagate candidate transactions? I should just keep it for myself. Maybe one day I create a block and I put them inside. I have no interest in propagating them to other nodes in the network. But if I do that, I break the whole network. So technically, today we could already use the existing Masa network to gossip this data. Nothing prevents us from piggybacking on transactions. Nodes that want will propagate it. Nodes who don't want are actually already harming the network. So that doesn't change anything. Here we will just add an API that allows anyone to propagate anything, not just transactions. It's already possible actually. Inside transactions, I can put anything, and the nodes will already do it. So in a sense, it's not at all a departure from what the Masa nodes are already doing. I hope that answers the question, but if you have more deep questions, feel free to ask. Then, well, there's the two other big aspects, the post-quantum double ratchet, end-to-end encryption, and plausible deniability. Well, this is quite technical. I'm gonna leave these ones on the side for now. I'll do a full session on this soon with you guys to explain exactly how this works. And here as well, we have quite a few innovations, and I would be very proud to share. So the project has just started. It's very new. Here, where we are at, we are at a point where the cryptographic wrappers are implemented and unit tested, so we can already start using them. We are finalizing the first version of the user interface to be able to probe things, to play with it, and to see what works, what doesn't. We are preparing a mock backend for the gossip propagation. So while at the beginning we won't be using the Masa nodes, we're going to create some kind of mock server just to try things, see what we need exactly from the Masa network. And we are getting ready to aim for users way beyond Web3. We want it to be easy to use and the blockchain inside to be just a technical solution. We want it to be transparent and invisible. People are going to be using it just as they would be using Signal. So that's generally the idea. And we are currently in the phase of building this very intensely. What I recommend is that you guys follow our progress. We have our GitHub. So under the Masa Labs umbrella, there's a public repository called Gossip. Feel free to check it out. You're going to see all our development efforts there. There's already code, and we're already moving forward. there's going to be a website soon that's going to be hosted, of course, on the Masa decentralized web. Feel free to check it out as well. For now, it's not operational yet, but it's going to be online very soon. There's going to be an X channel as well. You'll be able to follow the news here as well. So that's kind of the general idea for now. We want to build this together with the community. So feel free to join these places. Feel free to track what we're doing. Feel free to ask us questions. Uh, as soon as we have a first working end-to-end demo, we are going to show you, and we're going to invite people from the community to play with it. We want your feedback. We want to know what you think. We want to develop with you. And so there's a few questions here. So what if everyone keeps adding apps to use the network protocol instead of the blockchain, like Gossip? Adding apps to use the network protocol instead of the blockchain? Well, actually, there's going to be a priority system. So first of all, there's going to be the proof of stake system is going to be used for security, and second, the peer-to-peer, the Gossip protocol underneath Masa will also be secured by the same conditions it has now. The Masa blocks are going to be prioritized, so it should not have consequences on the Masa network, even in case of flood. So that's kind of a general idea. How about introducing new type of memory in Masa, sleep zone, so that this zone can be accessed only by the owner and can prevent access for another address? Well, this is essentially already the case given smart contracts, but here we don't need the full consensus. So in a way, if we use the full consensus here, we would be overloading the nodes more than if we just use the gossip layer. Nodes are going to be overloaded without any reward? No, they won't be overloaded. They won't be overloaded because this thing is going to be prioritized lower. The gossip of this system is going to be prioritized lower than block propagation. So Masa will not have any impact. And on the other hand, so Masa will not be impacted. And on the other hand, it's gonna essentially use unused bandwidth for propagating these things. There's going to be a local cache, so it's gonna use unused space only if the node runners allow it. So from there, we will not force anything on the node runners. It's not a breaking system. From there, if node runners decide to opt out, they can. But overall, the idea is that we don't use anything that either breaks Masa or uses more than the existing resources that the node runners are setting forward. I hope this clarifies things a bit. Of course, that part is not defined fully yet. The idea is that the chat uses a general gossip system, whatever it is. It can be Masa now. Tomorrow, it can be something bridged and piggybacking on Ethereum transactions. It can be a mesh Bluetooth network. In the construction of the system, we don't assume anything about the underlying network. So Jiku is saying that something that can be shared with all nodes, but only the owner can access it. Well, that's kind of doable already with encrypted contents in smart contracts, right? So you can send encrypted data to a smart contract that's gonna store it, and only you can have the private key, and only you can decrypt it. That's something you can do. If we have a gossip system, it's the same. You can gossip something encrypted, and only you and the person you're targeting can see it. That's something that can be already done at both levels. We're just gonna use the underlying existing gossip network of Masa to propagate these messages. Okay. Thank you for all your questions, guys. So to summarize, we are creating a new decentralized chat app because the existing ones we have seen are not satisfactory. The goal is to fuse all the aspects that we need here for something that's really post chat control resilient. And the idea is that we're gonna start step by step together with the community. Very soon, we're gonna have a small demo to show you how it works, and we're gonna invite you to play with it to give us feedback. Uh, it's a bit like a testnet. It's gonna start as very rudimentary. First, there's going to be only peer-to-peer chats, and later we're gonna add group chats, etc., etc. So that's kind of the general idea. And Giku is saying, can we return error when anything try to get data from storage? Uh, no, we cannot really prevent anybody from reading the public data on the blockchain. Uh, but what can be done is encrypt the data before you store it on the blockchain, and then you can read it back, and only you can read it. Uh, just being a node, you're gonna download the whole state. You cannot prevent anybody from accessing it. Yes, all this is in the roadmap. The roadmap will be released soon. So for now, we're building the websites and everything. We're gonna announce it very soon. Okay, I hope this has clarified quite a few questions. So don't worry, everything is still very preliminary. We are not forcing anything on the node runners. What we're doing here is just building a temporary central server that's gonna act as a mock for the gossip part, for us to be able to try things. And as soon as we're happy with how it works, then we're gonna set up the gossip part. So the thing that's gonna effectively propagate data and store it temporarily in a cache that lasts only 2 weeks. And hopefully this is gonna end up being some amazing chat app that people are gonna be using, even outside of Web3, because it's designed to be easy to use. The goal being that there is no barriers to use it, there's no possible censorship, and it's ready for all the future attempts at censoring it. And that's it. Perfect. Thank you. Thanks everyone for tuning in. Stay tuned. There's going to be a lot of new stuff. This is a very active development, so feel free to track what we're doing on all these media. And if you have any questions, feel free to ask them as well. In the meantime, I'm going to be doing weekly calls like this to keep you updated on everything that we're doing and tell you all the news every time there is something to mention. Well, thank you everyone, and see you in the next one.